Our next speaker is Tim Friar. He's with an organization here in town called Design Central. They're a full-service product design, product development organization, and he's going to tell you a lot more about them and what they can do and how that pertains to your interests in developing new products. Tim Friar.
Thank you. All right. Okay, here we are at Design Central. This is the front entrance of our offices that are in northern Columbus here, just inside of Westerville. And we're going to take you a tour, basically, of the services we offer and the things that we do. Almost 30 years ago, when Design Central started, we were thought of as a traditional product development firm. But as was stated a little bit ago, we really see ourselves as more full service now, really as an innovation consultancy. I'm not going to read all of these things to you. I'm going to actually move very quickly through quite a few slides to give you an overview. We are almost 30 years old. We're based here in Columbus, but we do work globally with manufacturers in all types of industries, including medical and consumer products, industrial products as well. What we do is empower organizations to grow and innovate. We help them in many different ways, as you'll see through some of the case studies I have here and some of the things I'm going to talk about. The tools we use, I'm going to go through in a little bit of detail, this list. Innovation strategy is really about processes and business processes and helping the companies that we work with in whatever stage they're in, whether it could be a startup or a major corporation like Procter & Gamble that we work with extensively here in Ohio. We do work with quite a few Ohio-based companies as well. Midmark, Crown are some of the larger companies that are here in Ohio, and also medical companies like Zimmer and Midmark. I'll let you read some of these things in the packet that you received. In terms of research, a little bit was talked about earlier in terms of the process, in terms of product development. We have researchers on staff that do product-based research, so it's qualitative in nature, not quantitative in nature. We can bring in some of the quantitative work, but we're really looking at the ideal and the needs of the user when we're doing that research. And again, that can range through from consumer products through medical products. Some of the ideas and concepts of the tools that we use are going to be the same for all industries. The traditional part of our work is really here. So some of the things that we've done for industries over the years, the concept sketching, the blue sky exploration of an industry comes to us and says that they have a category they want to work in, but they need conceptualization. We do a lot of work for Hillrom in this category in the medical market, where they'll come and say they're looking at a particular area that they want to work in, and we'll do hundreds of sketches for them just around thinking about that. Brand attributions, Crown Equipment is here in Ohio. They are a preeminent company in terms of lift trucks. And I know we're talking about medical here, but when we're talking about brand, Crown of any company in the world probably does as good a job as anybody in terms of bringing forward brand and product design. So we've got a couple of case studies of that here. We do have a medical product on the right side there. You can see some of the kitchen appliances here when we're talking about brand attributes and looking at things across the line. This is important when you're talking about major manufacturers in the medical industry, when they want to basically do something with not just one product, but a whole line of products, and have that be a product line that has similar attributes in terms of visual tools they're going to use. So the tools that we can use here in terms of solid surfacing, so we're using things like ProEngineer, SolidWorks, in terms of what we do. Photorealistic renderings, Keyshot, we use a lot of those tools, and then color analysis and mock-up. We'll see a little bit more of those. User experience. So at Ohio State, the people that we work with come out of the design program and the engineering program, and the two areas in terms of the design program that Reinhardt's from is you'll have the industrial designers and the visual communications majors. Here, the visual communications majors, we have 2 OSU graduates that are on a team that do the user experience. The product that I'm going to do a little bit of case study on in a few minutes is the Zimmer tourniquet that's in the center here. But the team that we have is fully capable of doing a full range of helping bring products to market in terms of user experience and visual communications. The engineering side of it, we actually do have a couple positions open engineering, so if anybody's looking, and not in this group, of course, y'all got great jobs. If you know anybody, send them our way. But we do mechanical engineering. Obviously, some of the things that you guys are doing that I've heard about today are way over our heads. But in terms of the things that, and bringing products to life in terms of the mechanical engineering, we do a very extensive work. So you see on the right, there's a floor cleaner for Hoover where there's 300 or 400 parts. We've taken that product from conceptualization all the way through this process to where we're handing off tool-ready, solid models to manufacturing or to the molders to be cut steel to make those parts. And we do that day in and day out with manufacturers across all different types of industries. So all of these things are processes and methodology that we use in-house to help that happen. A lot of things you see here are going to be testing as well as you've got some thermal testing going on, you've got some drop testing going on there, and then some thermal testing with that lighting science piece up here in terms of what's happening in the construction of that. The prototype development, I was asked to speak a little bit more about prototype development today. So I'm going to flash through a couple of case studies after this, but here are the types of prototypes we do. So engineering prototypes, functional mock-up, rapid prototypes, breadboards was already mentioned, appearance models to make it look like real, and then short-run production if somebody just wants to get into market. We help facilitate all of those things. And then the processes that we use are through here. And I've got a couple samples on the table over there. They're not necessarily medical products. They're things that I could fit in a case. But you're going to see a lot of CNC machined parts to look at mock-ups and how those works. SLA or stereothography is raising out of a resin bath. I'm sure you guys know things about that. We're going to hear more about 3D printing later. Selective laser sintering is another process, not as used as much as some of the others, and so on and so forth. A lot of cast urethane parts that we'll use as well in what we're doing with our processes. The Zimmer tourniquet, I'm going to go through a quick case study of how we help this company from research, design, all the way through implementation of their product. This was their prior product that they had. They understand the core technology very well in terms of the tourniquet. It's used for bloodless surgery in the operatory. Very critical product, works very well. They were state of the industry. These are actually appearance models that we created for them through this process. So we took it from an analog product to a fully digital product where we did all of the user interface, all of the design work. So we're starting with the process, working with the physicians, working with the stakeholders that are involved in the process, and mapping out how the product's going to work. And then detailing that a little bit more, and then looking at specifically, because really what this is about, it's about user interface and moving that from the analog to the digital and not losing anything because it's such a critical product in terms of how it operates. Because those stakeholders, when they're moving to a product like this, they don't want to have missteps in the training or in any step away. So we're looking at detail in here, and there was hundreds of screens that were developed by our visual communications UX team that were then communicated them to code in the actual product. And you can see some of those representations here. And then the critical part of it, lots of interaction, lots of patent development, IP on this in terms of just the motions on the screen and how the screen actually is touchable and movable and pieces like that. A lot of work done both our team and the Zimmer team. And then we turned over a full package of icons, design to Zimmer, and again, then that was coded into the product. At the same time, we're working not only on the visual communications, but then the exterior enclosure of the product, where we're starting with the internal architecture of the current product, adding the screen, taking their components, doing conceptualization around that, and then a little bit more refined conceptualization, deciding which version we're going to move forward with, and then meeting with the client, working with them to come to this. And these are actually our prototypes that we built in our lab at the offices. The product that you'll see on the shelf or in the operatory looks exactly like this. Basically, you couldn't tell the difference of it. I had to talk to the team over and over. That really is our product, and it was. So the product, and I saw some of those up at Zimmer that were the first production run. So again, the same image here. I'm going to flash through a couple other projects, not as many, but this was a device that we did for Endolap before they were part of Cardinal Health. They were looking at a way to move the trocar through the opening without having it catch. So all of these prototypes that are on the table here are prototypes that we made in our lab. So there's a lot of silicone overmolding going on, and I actually have samples of some of these in the box over here. So a lot of experimentation on our part. Obviously, we're not the ones that are going to bring this to market or bring it through the FDA, but we can help conceptualize on things like this, and we do this every day. And then this was something that actually did go to market where we're using, you can see the intellectual property drawings here. And here what's happening is there's a hard plastic surface and a silicone body. The silicone does the sealing, and then the hard plastic surface, something that the mechanism can go through, the device can go through without scraping on it, so that it goes through smoothly, and then it retracts. It retracts quickly and efficiently, so it closes off the opening that's in the body for the surgery. This is not a medical device, but it could be used in the medical environment. It's an upside-down keyboard. Basically, this is the bottom of it, so you're going to type on the back side of it. It could be used for if somebody wants to do data input. This is all a prototype that we built. So you can see we've basically built the enclosure and then take existing keyboard parts to make something very quickly, put that in, made it fully functional. This person introduced this at CES, had phenomenal response. It was all over the web, all over the world back in January. This was done as a rough prototype, just a CNC cutout to get the form, shape, feel, size of it before we went into the design and quickly generating the prototypes that were used for CES. And then there's top view of that. So it actually, as you hit strokes of the keys on the bottom side, it will light up the keys on the top side to tell you that you've registered. Obviously, it takes a little bit of training to use it, but once you do, you can become almost efficient if you're a typist, touch typist, as you are on a keyboard. But you could the idea is you would have a small tablet device in the center of this, and you could use that, and it would be showing up on the tablet device as you walk along. Or you could even use it connected to your desktop and walk around in your environment. The idea is it would not be wired in the future product, but for the sake of the prototype, it was wired. Another prototype, this is SLAs that will have the very functional part for this breast biopsy device that we helped innovate on. So this is a very truncated part of our process where initially we'll look at how that product's going to be look and used and feel in terms of the product. And then we'll go into rough mock-ups. And you'll see that we've got quite a few mock-ups here in terms of changing the pivot on it, how the hand is holding it upside down, right side up, that type of thing. And then this is the actual product in play. And these are actually photographic renderings that were done by our team for a concept around this product. There's a lot of reasons why the product that goes to market in this case is different than from what we might have conceptualized, but functionally it did the same thing as what we conceptualized around. Different than the Zimmer, where what went to market was exactly what we designed. So you see some of both in terms of what we do. I believe this is the last case study that I have that I'll go through quickly. But this is an instant wet milling system. A pharmacist that was from Pennsylvania moved to Columbus to work with the Tech Columbus group that was mentioned earlier. He has an office there. And the idea of the product is that when a person can't swallow a med or even a med that's been crushed, and you also have issues around contamination when you crush a med, the idea this would be used in the hospital first. So the physician would prescribe the medication, the pharmacist would compound it. Normally they would crush that and then add it to a liquid. And that's, there's issues with contamination through that. There's issues with, in terms of the compounding issues, and can you get it fine enough? So this is a product that would solve all of this. So we're looking at conceptualization, and in this case, he already had a pretty good idea what it was. He was not looking for a great-looking product like what I showed in the first rendering. He was just looking to a proof of concept prototype to show that this concept worked, and that's what we built for him so he could go out and get funding for the product. So what we're looking at is basically a centrifuge that spins the medicine, that does the wet milling at a very rapid rate. The novel part of this is that a liquid would be put in the vial and the medication would be put in the vial, and that would become a disposable unit, similar to what we heard earlier with the razor blade thing, that the device would potentially be given away at a low cost, and they would sell many of the containers. The benefits of that obviously is that you're not transferring the medicine out of the container, so you're not having a loss of the medicine. You're also not having the contamination issues that you have with crushing that you do right now. So what we're doing in our lab is building prototypes, very, very quick prototypes to prove the concept. Refining that, you see there was 2 on the spindle before, now there's 3. We're looking at different types of motors and mechanisms to make that work very rapidly. And then going in to develop a prototype frame that could be built around, and you can see the actual container here. And then this is what we built for him to take out into the world to show this product to different users. And so this is actually an operational unit. It's not looks the greatest unit, but it's a proof of concept prototype that can be used, and it does demonstrate the concept. I mean, it does work, totally functional in terms of what it does. This is some of our team back at the Design Central, and these are some of the companies that we work with. So these are the bigger companies. We work with a lot of startups as well. So if I can answer any questions, I'd love to. And I did bring quite a few samples of these different types of prototypes over here. I think I did it in 20 minutes. 47 slides. Okay, thank you.